What if the universe just blinked at us? Not once, but over and over again. In late 2025, telescopes across the world caught something no one could explain. An interstellar object named 3I-ATLAS, flashing bursts of blue light deep in space. They weren't random. They were rhythmic, precise. The flashes repeated every 20 seconds, like a heartbeat in the dark. NASA called it a reflection, but others believe it was a signal, and it's getting brighter. The night the sky turned blue, it began quietly without warning. On a cold night in October 2025, skywatchers in Chile, Arizona, and southern Spain reported seeing something strange through their telescopes. A flicker faint at first, coming from a region of the sky where 3I-ATLAS was known to be passing. At first, it looked like a reflection, a trick of sunlight bouncing off its icy surface. But within hours, that theory fell apart. The light wasn't constant. It was pulsing. Every 20 seconds, a sharp blue flash cut through the darkness, visible even through layers of cosmic dust. Amateur astronomers began flooding online forums with identical observations. A cold electric blue flicker repeating like clockwork. By midnight, even NASA's deep space cameras confirmed the anomaly. The object was emitting light in short, deliberate bursts, each identical in brightness and duration. Natural reflections don't behave that way. What made the event even stranger was the timing. 3I-ATLAS had just passed near the orbit of Mars. Far enough that sunlight alone couldn't explain such intensity. To shine that brightly, it would have needed to reflect light from a source thousands of times stronger than the sun or generate the light itself. That last part terrified scientists. NASA initially dismissed it as sensor noise, an optical illusion caused by charged particle. But data from multiple observatories, including the Very Large Telescope in Chile and Japan's Subaru Telescope, showed the same result. The light was real. It was repeating and it was blue, radiating at a wavelength centered around 470 nanometer, consistent with ionized plasma emissions, not reflected sunlight. The rhythm that shouldn't exist. By dawn, it was undeniable. The pattern coming from 3I-ATLAS wasn't random. It followed a rhythm so consistent it resembled a coded pulse. The flashes occurred every 20 seconds, each lasting less than half a second. And every pulse carried the same energy level across different observatories. The wavelength remained fixed as if controlled by a single mechanism repeating itself with perfect accuracy. In space, chaos is the rule. Nothing this precise happens naturally. NASA's Solar and Heliospheric Observatory confirmed that the light wasn't coming from any known reflection or solar interference. Instead, the emission came directly from the object itself. That revelation turned a simple observation into a global mystery. The idea of a comet or asteroid generating light was unheard of. Comets reflect sunlight. They don't emit it. Yet, here was 3I-ATLAS blinking blue across the void like a cosmic beacon. Then came the most disturbing discovery. When scientists plotted the timing of the flashes, they realized the sequence wasn't just evenly spaced. It followed a mathematical ratio, one found in natural harmonics and sound frequencies. The pattern mirrored the same progression used in radio beacons and deep space transmissions. It wasn't random, it was structured. When NASA finally looked closer, it took NASA less than 48 hours to realize they couldn't ignore it any longer. By then, the blue flashes from 3I-ATLAS were visible even in low-orbit satellite feeds. The object had brightened by nearly 60% in just 2 days. Far too much for reflection and far too stable for a chemical reaction. Every known explanation was crumbling and the blue light was becoming more organized, almost deliberate. Behind the scenes, NASA redirected the James Webb Space Telescope for a priority observation. The order wasn't public, but leaked scheduling logs later confirmed it. On October 2, Webb turned its powerful infrared eyes toward the coordinates of 3I-ATLAS. For over 3 hours, it tracked the object as it drifted through interplanetary space, recording every wavelength of radiation it released. The data shocked everyone involved. Instead of a natural emission spectrum, the kind you'd expect from heated gases or dust, the readings showed sharp, isolated peaks. Those peaks were too narrow, too uniform. They looked engineered, like something was controlling the output to stay within a specific frequency band. It wasn't behaving like a comet. It was behaving like a transmitter. When the data was cross-checked against known emission types, one detail stood out. The light carried polarized alignment, meaning the waves were all moving in the same direction. That's something that happens in lasers, not in nature. The blue flashes were coherent light and an unmistakable signature of artificial emission. The signal hidden in the light. When the leaked data from the Webb telescope hit the scientific underground, researchers everywhere started decoding. What they found made the blue flashes even more terrifying. The rhythm wasn't just steady, it carried embedded layers of modulation, almost like a binary structure woven into the light itself. When converted into frequency waves, faint peaks appeared in repeating groups of 3, separated by identical gaps. That pattern wasn't natural. It was information. Across the globe, data analysts, cryptographers, and amateur radio experts joined the hunt. Some believed the blue flashes were simply byproducts of ionized gases interacting with cosmic rays. But others, especially those who had worked in radio astronomy, knew better. The precision, the timing, the symmetry, everything about it resembled controlled emission. It was as if 3I-ATLAS was speaking, but in a language made of light instead of words. NASA remained silent. No official acknowledgement, no updates, not even a denial. The only sign that something was happening came from sudden telescope maintenance notices. The European Space Agency restricted all observation requests for that region of the sky. Even private satellite networks like Starlink quietly routed certain frequencies, blocking civilian detection. Whatever 3I-ATLAS was transmitting, it was something no one wanted spreading uncontrolled. Then came the breakthrough. A small research group at MIT using archived frames from Webb's unfiltered raw data noticed that each burst carried a slight time dilation between wavelengths, an almost imperceptible delay that repeated every third flash. When converted into a sequence, that delay formed a numeric ratio matching the Fibonacci sequence. One of the most fundamental patterns in nature. But the strangest part was still coming. In the final 10 minutes of Webb's observation window, the light changed. The flashes became faster, shrinking from 16 seconds apart to 12, then 10. And at that exact moment, ground-based telescopes across 3 continents recorded the same anomaly, a sudden electromagnetic ripple that coincided perfectly with the flash sequence. When the blue light reached Earth's orbit, by the second week of October 2025, the blue flashes from 3I-ATLAS were no longer just visible through deep space telescopes. They began interfering with instruments in Earth's orbit. Weather satellites, communication arrays, and even the ISS reported faint disturbances aligning perfectly with each pulse of the blue light. It wasn't destructive, but it was undeniable. Every 16 seconds, sensors across low Earth orbit flickered. The signal had reached us. At first, engineers blamed solar activity, but there were no flares, no radiation spikes, nothing that could explain the timing. The interference wasn't random static. It carried the same wavelength as the light bursts from 3I-ATLAS. Each cycle started weakly, then intensified before fading out again. A heartbeat of energy sweeping through our planet's upper atmosphere. Then something else happened. Ground-based magnetometers across the northern hemisphere recorded small synchronized tremors in the geomagnetic field. These distortions weren't powerful enough to damage anything, but they pulsed at the same rhythm as the light. The effect repeated 3 times before fading, just long enough for scientists to confirm that it wasn't a coincidence. Somehow the energy coming from 3I-ATLAS was interacting with Earth's magnetic shield. NASA quietly issued internal alerts to suspend all non-essential satellite experiments. Meanwhile, the James Webb team was ordered to stop tracking the object for operational safety, but not everyone obeyed. Independent researchers in Chile using smaller telescopes continued monitoring the blue flashes. Their results showed something deeply unsettling. The flashes were now stretching into elongated streaks like beams pointing directly through the void. The pulse that entered our atmosphere. It started as a whisper in the data. Too faint to notice at first. Then just after midnight on October 18, the first real pulse hit. Satellites over the Pacific detected an electromagnetic surge rippling through the ionosphere synchronized exactly with the timing of 3I-ATLAS's flashes. For 2.5 seconds, the upper atmosphere shimmered in ultraviolet bands invisible to human eyes, but clear as day on scientific instruments. What unsettled scientists most was its precision. Each burst arrived precisely 8.44 minutes after emission, exactly the time it would take light to travel from the comet's position to Earth. That meant the object wasn't reacting to us after the fact. It was predicting our location in real time. Whatever was driving 3I-ATLAS understood orbital mechanics perfectly. Within hours, the pulse effects began to spread. Power grids in coastal observatories flickered. Radio telescopes temporarily went offline, not because of overload, but because their systems couldn't synchronize with the incoming frequency. The signal carried a distinct resonance near 1420 MHz, the same frequency associated with hydrogen emission, the one many SETI researchers had long believed aliens might use to communicate. By the third pulse cycle, the pattern evolved again. Instead of short bursts, the energy arrived in clusters of 3, each one slightly overlapping, like overlapping musical chords. Those who recorded it noticed a disturbing trend, and the intervals matched the same Fibonacci sequence encoded in the original signal. The day the sky flashed blue, October 23, 2025. The day began like any other until the sky changed. At exactly 3:14 Universal Time Coordinated, an electric blue shimmer spread across the upper atmosphere, visible from Hawaii to Western Australia. Airline pilots reported flashes above the clouds, silent, colors-saturated streaks of light, unlike lightning or auroras. In Japan, night sky cameras captured something terrifying. 3 consecutive bursts, perfectly spaced 16 seconds apart, sweeping across the horizon like silent explosion. The flashes weren't isolated anymore. They were global. Energy detectors across NASA, ESA, and JAXA all recorded simultaneous spikes in the 470 nanometer band. That wavelength matched the blue emission from 3I-ATLAS exactly. Whatever was happening up there, it wasn't reflecting sunlight. It was synchronized with the comet's pulse cycle. For a full 6 minutes, the world watched the atmosphere flicker like a living thing. In the skies over the Pacific, satellites captured something else. Thin ring-shaped waves expanding outward, almost like shock ripples, but made entirely of light. Each one corresponded to a pulse from 3I-ATLAS traveling outward from the point on Earth facing it directly. When scientists mapped those points, a strange geometry appeared. The flashes weren't random. They formed a triangle spanning 3 regions: Chile, Indonesia, and Madagascar. Each one equidistant from the next. No natural phenomenon on Earth aligns like that, especially not from a distant comet. Within hours, the internet was flooded with footage of grainy blue bursts caught on security cameras, glowing skies reflected in ocean waves, and reports of strange electromagnetic interference. Car alarms triggered themselves. Radios emitted static bursts at exact 16-second intervals. Cell towers recorded unexplained surges. The coordinates hidden in the flash. When the blue flashes ended, scientists thought the worst was over. But what came next was far more unsettling. As data from observatories poured in, NASA analysts noticed something odd. Please like and subscribe channel.